Hi everyone and welcome back to a new intermediate Spring Boot video. In this episode, we'll try to create a Spring Boot application using the Kotlin programming language. Now, Kotlin is a statically typed programming language that runs on the JVM. I think of it as a kind of Java, but with more features, a modern version, if you will, of Java. What you need to know is that Kotlin is 100% compatible with existing Java code. In fact, you can even write Kotlin classes and Java classes in the same project, so you have a high degree of intercompatibility. Okay, but that being said, why should you care about Kotlin and why would you like to use it? Well, first of all, Kotlin has a very high growth rate. If you look at the graph below, you can see that the use of Kotlin literally exploded in the last year or so. And this is also due to the fact that Google decided to make Kotlin the official language that is used for building Android applications. And I think this is a really positive sign that Kotlin is here to stay. Last but not least, Kotlin is very modern. So I think it's more elegant than Java because we have type inference. So we have the volume var keywords, we have immutable types, we have cleaner lambdas, and we have a very brief syntax that tries to eliminate a lot of boilerplate code. Now, that being said, what is this tutorial about? Well, we'll try to see how easy or difficult it is to build a Spring Boot application using Kotlin instead of Java. Before we get started, I want you to know that I've never built a Spring Boot application using Kotlin in production, so I don't have experience with using Kotlin in real life applications. I'm very passionate about it. I've watched a lot of tutorials, I read a lot of blog posts, and I played around with it, but I definitely do not have production level experience with Kotlin. So if you really want to take this topic and create real-life applications with it, then I strongly suggest that you check out other resources and that you study Kotlin and the integration between Kotlin and Spring Boot in depth. This is just introduction to intermediate level Spring Boot Kotlin video. So it's actually it's my first time that I tried to write Spring Boot apps using Kotlin. So we'll see how that goes. Okay. That being said, I think it's time to leave the slides and jump into some code. To create a new project, we'll go to start.spring.io and we have the Spring Initializer webpage. So I want to generate a Maven project with Kotlin. Okay, we'll use the current Spring Boot version 1.5.9, and let's say the group is RC. The name should be Spring Boot Kotlin demo, and I want to get web dependency, JPA, and H2. Okay, that should be enough. Okay, I'll hit generate project, and I have this zip over here. I'll copy it, and I'll paste it here. We'll unzip it. Okay, now I can delete this archive, and now I should be able to open it with IntelliJ. So I have the latest version of IntelliJ 2017.3, and we'll see that it has a pretty cool feature for making REST calls from within the IDE. Okay, so I'll import the project and I'll go to GitHub, Romanian coder examples, Kotlin demo, and we'll open the pom.xml. Okay, next, okay, next, and that should be it. And now we should have a new Spring Boot application based on Kotlin skeleton. We'll just give it a couple of seconds to resolve all the dependencies. Okay, and now we have the basic project structure. So as you can see, it's very similar to a standard from what you would expect from a normal Spring Boot application. The only difference is that now we have Kotlin instead of Java, but the structure is absolutely the same. Now, before we get started, let's take a little look on the pom.xml file. Okay, so I'll open the pom.xml. Okay, so we have standard stuff in here. We have the parent, which is the Spring Boot starter parent. Okay, nothing new under the sun. Okay, we have a Kotlin version here, which is specific to Kotlin projects. Okay, but not something different. We have the dependencies, starter JPA, starter web, and now we have a couple of dependencies that are needed for Kotlin-based projects. Now, the Kotlin standard library and the Kotlin reflect library. And now we have the H2 database and the Spring Boot starter test. Okay, nothing under the sun. And now what's different is this build plugin. So this part here is a little bit different from what we had in normal Java projects. But basically what we have here, we have the Kotlin Maven plugin that is used to compile our Kotlin classes into bytecode. So we need this build plugin if you want to develop applications using Kotlin. And we also have this dependency on Kotlin Maven all open, and this is useful because in Kotlin, unlike in Java, the classes are marked as final by default, and we know that Spring utilizes a lot of proxies and it subclasses a lot of our existing classes, and if the classes are final, then Spring cannot do that, and then we have all sorts of problems. And that's the reason why you see this dependency here, Kotlin Maven all open, which in fact turns some specific Spring classes and marks them as open so they can be inherited. But other than this rather almost complicated looking build plugin, there is nothing special about a Spring Boot application using Kotlin. So even if you've never used it before, I don't think you'll have problems understanding the structure and the POM file. Let's take a little look on the main application. Okay, so this is the entry point into our Spring Boot application, the main class. Okay, it's annotated with @Spring Boot application, exactly like standard app written in Java. What's a little bit tricky here is this function main. So in Java, we have static classes and we write them inside the class, but in Kotlin we cannot do that. So we don't have a static modifier. And basically all the static functions that we want to create, we create them outside of the class, and then they're like package based static functions. So that's why we have the main function outside the Kotlin class, because this is the way that we emulate, let's say, static classes in Kotlin. But even with this, I think the main class, the code here is pretty readable. Let's run this and see if this application works out of the box. Okay, so our application has started. Okay, we have everything is initializing, and look, we have Tomcat started on port 8080 and the Kotlin app started successfully. So out of the box, when you build a Kotlin app using the Spring initializer, you get a fully working application, and that's great. Okay, now let's try to write our own code here, shall we? Let's create our first entity. I'll go ahead and create a Kotlin class, and let's say we want to create a hotel entity. Okay, in Kotlin we can use inline constructors as primary constructors. Therefore I want a hotel name of type string. I want the classification of type integer, and I have to declare it like this. And I also need the name classification and number of rooms. of type integer. Okay, and we also need two mutable fields. So I have id of type long equals 0, and I also have number of free rooms of type int, which initially is the number of rooms. Okay, so with 4 lines of code, I created a class with 5 fields, 5 properties, and a constructor. Now, let's take a closer look of what's happening here. Now, notice the val and var keywords. In Kotlin, we have immutable types, immutable types. When we prefix a property or a variable with val, it means that it is immutable. So it works like final in Java terminology. And then var marks a property or a variable as being mutable, so we can change it after we initialized it. Let's create a couple of functions here. So I have a function for checking in guests, and I have number of guests of type int, and I want a function for checking guests out. Again, number of guests of type int. Okay, so we can if number of free rooms is greater, okay, then we can say this number of free rooms minus equal number of guests. Okay, and here we just say this number of free rooms plus equal number of guests. Okay, cool. Okay, and we have two functions declared. Notice that we are not using semicolons. I mean, we can use semicolons, but they're optional in Kotlin. And now we have all that needs to be done is to, place in the specific annotations, the GP annotations. So we mark the hotel as an entity and the ID field as an ID, and the generation strategy is going to be auto. Okay, so this is my hotel entity written in Kotlin. We have 3 immutable properties, 2 mutable properties, and 2 methods. Now these properties act like a getter and a setter. We don't need to declare getters and setters in Kotlin. And of course, if you want to, we can make these properties, read-only, or we can grant them read and write access. But for the sake of keeping things simple, I'll just implement them as, read-write properties. Just for comparison's sake, I will create the same hotel entity in Java. So I'll have a hotel Java. Okay. We'll annotate it with entity, and now we'll have a private ID of type long. We'll have private string name. We'll have a private int classification. We'll have a private int number of rooms, and we'll have a private int number of free rooms. We need a constructor, so hotel Java, and we need the name, we need the classification, and we need the number of rooms. And we need to bind this, we need to bind these parameters to the fields. And now we need the getters and setters for each and every one of them. Okay, we have getters and setters. I also need to add in the ID here. And now we have the 2 functions. So we have public void checkin. Okay, I'm not going to implement them. And public void checkout. And I'm not going to implement this one either. Okay, and now we can compare them. So in Java, for writing the same entity, we used 70 lines of code, and in Kotlin we have 24 lines of code. So I think that the difference is, you know, pretty observable. And this is one thing that I particularly like about Kotlin, because it's a very succinct, it's a language that doesn't force you to write a lot of boilerplate code, and therefore you have a smaller code base, and implicitly you have a more maintainable code base. And if you multiply this, I mean, we're talking about a very simple entity here, a very simple class, but if you have a real life project with, you know, hundreds or maybe thousands of classes, you can imagine, you know, the impact on the number of lines of code that you'll have in your project. So this is one thing that I really like about Kotlin, the fact that we can express things in a more, you know, succinct way. Cool. Now let's go ahead and create a repository and a database seeder. Okay, for a repository, we'll create a Kotlin interface. We'll call it hotel repository, and we'll annotate this with @repository, and this interface is going to extend the CRUD repository interface of type hotel, and the ID is long. And we're also going to add a custom method, find by name, which is going to retrieve the hotels based on a certain name. So we have name of type string, and this is going to return a list of hotels. Cool, so this is my hotel repository. The only thing that looks a little different from Java is how we extend or how we implement interfaces. Now in Java we have the associated keywords, implements and extends. In Kotlin instead, for brevity's sake, we use the double dot sign. So we have an interface hotel repository which extends the CRUD repository, you know, etc, etc. And now let's go ahead and create a command line runner. Again, we're going to use Kotlin and populate our database with a couple of hotels. So we're going to have a Kotlin class. We'll call it database seeder. We're going to annotate it with @component, and now we're going to implement the command line runner interface. Now again, notice that I'm not using a keyword, I'm using the double dot sign to implement an interface. Okay, I'm going to implement this member, which is the run function. Okay, we'll delete this. And the database seeder needs to have a reference to hotel repository, so it has a dependency on hotel repository. And again, we can use the inline constructor to make this possible. So I'll declare a final, so a read-only hotel repository of type hotel repository. And now when Spring will fire up, and the standard, you know, component scan and dependency injection mechanism will happen, and the hotel repository will be injected in here. And I'm just using the inline constructor to save myself some space. And let's go ahead and implement this. So I have hotel repository. We'll delete all the existing entries if we have some. And now we're going to create a couple of hotels. So I'm using, let's say, Ibis. I'm creating a new hotel. The name is Ibis. We have a 3-star classification, and we have like 30 available rooms. This is the way that in which you create objects in Kotlin. We have a valor of var keyword. So if you want to have a mutable object, we annotate it with var, we prefix it with var. If you want to have an object that is immutable after we initialize it, we can use the val keyword. And then notice that we don't have a new keyword. In Kotlin, we just have to specify the class name and the parameters for the constructor. We don't need to specify the new keyword. And of course, we have type inference. In Java, we would have written hotel ibis equals new hotel, blah, blah, blah. Here, we just declare val. And because we have very powerful type inference, then you know, the compiler knows that ibis is actually a hotel instance. So we have IntelliSense, code completion, etc, etc. Let's go ahead and do the same things for the other hotels. So I'm going to create a couple of hotels. I'm going to create, a 5-star hotel, and this has, 90 rooms. And I'm also going to create a 4-star hotel, but I'm going to create it a little bit differently. So I'm going to use named arguments. So I'm writing hotel equals, golden tulip, classification equals 4, and number of rooms equals let's say 40. Okay, so this is just another way to that you can use when you pass in arguments. You can pass them by default, and if you have IntelliJ, you have the names of those parameters in here highlighted in gray, or you can actually pass the parameters with their name in order to make the code more clear. Now in this case maybe we don't need it, but if you have a method or something that takes in a couple of boolean parameters, then it will make the code a whole lot easier if you add the name of that parameter as well. Okay, let's create a list of hotels, and we're going to use the utility function that we have from the Kotlin standard library, list of hotel. Okay, and you would expect that we can write hotels add, but okay, there is no add method. That's because in Kotlin, lists collections can be mutable or immutable, and when we use list of, we are basically declaring an immutable collection, and we cannot add or remove elements. Now if we want to perform these operations, we need to create a mutable list of hotels, and now we can say, okay, I can add my hotels to this list. Golden tulip, and now I can save them using the hotel repository, using the save method. I can save my hotels, and I also want to to print that I have successfully saved these hotels in the database. Hotels actually, okay, and I'm using this just as a signal that our code works. Cool. Now let's fire up the application and see if the command line runner gets executed and if the database gets populated. Okay, the application started on port 8080. The database has been initialized, so everything appears to be working perfectly until now. One last thing that we need to add here is the REST controllers. Adding a REST controller should also be pretty simple. Okay, we're going to call it hotel controller, and it's going to be a Kotlin class. We will annotate it with the REST controller annotation, and we're going to have a request mapping annotation, and let's say hotels. Cool. The hotel controller will have a dependency on the hotel repository. So we create an inline constructor, and we have it. And now let's create some get and post methods. First, let's try to retrieve all the hotels. So we have a function, let's say all hotels, which is going to return a list of hotel. Okay, and we're going to return this hotel repository find all. I think it should be like this. Okay, because find all returns a mutable list. Okay, so I need to change the type here to be mutable because this is a mutable list. Okay, and now we can add in a get mapping, and we can call it, say, all. Now, because this is a very short method, we can actually declare it in line. So what this means is I can actually say this method equals this dot hotel repository find all, and that's it. Basically, I have a one-line method for retrieving all the hotel instances. Let's do the same thing for find by name. So we have a get mapping, and we're going to say hotels, and we're going to pass in the name. Okay, and I'm going to create a collection here, var sorry, no, I made a mistake, because this is the get mapping, it's not the function, sorry. So we have function by name, it's going to receive a path variable parameter, path variable, which has the value name, because this is the name of the path variable, and it's going to be a name of type string. Okay, and now let's say val hotels by name equals this hotel repository find by name, and we pass in the name, and now we return hotels by name. And of course we need to have a return type here, list of hotels. Oh, sorry, not here, but here. Okay, so this is the method for returning hotels by name. And let's also create a post method. Let's say that we want to perform a check-in. Okay, so we have a post mapping, and we're going to allocate it to the check-in path. So we have a function check-in, and this is going to receive a request body, and we're going to receive an object of type check-in request, of type check-in request. Okay, so we're going to pass this object via JSON into this controller with the post method. Okay, and now we have to create this new type, and I want to check the compatibility with Java a little bit. So I want to create this class check-in request not as a Kotlin class but as a Java class, and then we can see if it works or not. So I'm going to create a Java class in here. I'm going to call it check-in request. Okay, and I need a private string hotel name, because you want to know the name of the hotel for the check-in, and a private int a number of guests. Okay, no, sorry, not this. I wanted to add getters and setters. Getter and setter for hotel name, getter and setter for number of guests. Okay, and you can see that we can use this type over here even though this one is written in Java. So we have a Java class, and besides it we have all these Kotlin classes and interfaces, so it appears that this is full compatibility between them, and this is pretty cool. Okay, so first let's find the hotel by name. So we have hotels by name. Okay, and we have this hotel repository find by name, and of course in our case we have a single hotel for that name, so I'm going to have get and this is the index, and now we need to pass in the name, so it's check-in request dot hotel name. Okay, and we get the first index, and then we have the hotel. Now of course in production you will not do this. You'll have a method in the repository that returns an optional of type hotel, and then we evaluate it, but okay, for simplicity's sake we'll do it like this. And now we can say hotel dot check-in, and we pass in the number of guests, so number of guests. Okay, and now we save the hotel back into our repository. and this should be it. So you see that we can access properties from the check-in request. Now we have hotel name and number of guests, and because we are in a Kotlin class, we can call them as if they were properties. So when we go to the check-in request, we have getters and setters, but because we are using this class in Kotlin, we can actually call these as if they are properties, as if this class were defined in Kotlin. Okay, so now we have our controller, and I think it's time to test our application and see what we got. Before we test our controller, I want to make a couple of changes to the existing code. First of all, I want to correct this one. We should be check-in, not checking. And also I need to rename the check-in request class because it's spelled incorrectly. So it's check-in request. Okay, awesome. Now I'll fire up the Spring Boot application, and okay, I can use Postman to test my REST controller. I can use a simple browser like Chrome to test my REST controller. But if you're using IntelliJ 2017.3 or beyond, you have a pretty cool feature for testing the backend part of your application. You can actually define HTTP files which encapsulate HTTP calls that you would use to test your app. So I'm going to create a new file. It's going to be hotels.http. Notice the extension here. It absolutely needs to be HTTP. Okay, and now I can define a GET request. HTTP is going to be localhost 8080/hotels/all, and the content type is going to be application JSON. And now you'll notice this little icon over here. You can actually run this request, and then you'll get the answer in the console. And in my case, apparently I have a 500 error, and the error message is no default constructor for entity hotel. Let's check this out. Okay. So when we created a primary constructor in Kotlin, basically we added a new constructor to our class, and that means that we no longer have the default constructor available and we need to create it. Well, in Kotlin, we can create additional constructors by using the constructor keyword. So I'm going to create a default constructor, and now instead of calling super and passing the parameters, we can use the double dot sign again, and we'll say this, and we'll pass in these three arguments: name, classification, and rooms. I'm just going to use default arguments, nothing fancy. Now I have a default controller, the default constructors, excuse me. Okay, I'll relaunch the application, and now we'll see if we have more luck executing this request. Okay, the application is online. Okay, I fire up this request, and there it is. We have the request, the response body over here. Notice the three hotels that we just created, and I didn't have to leave the ID, which I think is pretty cool. Now let's create another request here. Let's create a GET request that fetches hotels by name. Okay, and let me just add a comment in here as well that fetches all the hotels. So I create a GET HTTP localhost 8080 hotels. Actually no, I just need to pass in the name, so I'll pass in IBIS, and again the content type is application JSON. Let's see if this request works. No, I think it's hotels.ibis. Okay, and there is my IBIS hotel. Cool, so the GET request work. Let's test the POST request. So POST request to check in some guests. Made a spelling error there. Okay, so POST, we have HTTP localhost 8080. I think it's hotels.checkin, and now we need to define the content type again is application JSON, and now we need to define the object that we're going to send to our controller, this check-in request, which has two properties, the hotel name and the number of guests. Okay, so we can define it in here, if I remember correctly. So we have hotel name, and let's say it's Ibis, and we have number of guests, and let's say we want to check in 4 guests, and notice that there is like an empty line between the definition of the request and the object that we're about to send in. If I remove this line, I don't think it's going to work. I mean, in all the examples that I saw, this line was here. Now let's make a test. Okay, let's run this post mapping. Okay, so the status is 200, and now let's run this GET request to see if the number of rooms is modified. Okay, see, so notice the number of free rooms is now 26 because we checked in 4 guests. Now if I run this again and this again, we have free rooms 22. Okay, so our post request works as expected. Now I just have a small curiosity. I wonder if I remove this space from here, will this request actually work? No, actually it's a bad request. Okay, so when you generate post requests or put requests, make sure that you leave this empty line between the definition of the request and the actual payload of the request. Okay, so I just wanted to test our controller and show you a pretty cool feature in this new version of IntelliJ. And what I particularly like about it is that you can have these request snippets defined in your code base, and you can post them on Git, and then when a new developer comes in, he can play with them without ever leaving the IDE. And I think this is a pretty cool feature. Okay guys, that's it for today's video. If you enjoyed it, please hit the like button and share it with your friends. You can also find more software development articles on my blog at www.romaniancoder.com. I hope you enjoyed it. Have a great day and write amazing code. Goodbye.